Hi, welcome to this video where we're going to be looking at the SACE Specialist Mathematics Exam for 2019, and in this video we're looking at question 8. Okay, so question 8 was a question that involved doing some integration to solve a problem, and the problem is posted or posed like this. It says that the flight path of a fly is given by solutions to the differential equation below. And the differential equation is dy dx is equal to x times x squared minus 1 divided by y times 2y squared minus 1. Okay, and part A of this question is you're given a slope field in figure 7 and you need to draw the flight path that passes through the origin. Okay, so the point 0, 0. So if we go to the slope field, you can see here what we're looking at is the derivative for every sort of a grid point of values around the xy plane, and we want a path that basically follows these lines. So if we start from 0, 0, because we want a path that goes through there, you can see we're not going to be going straight up or down the x or y axis because the flow fields are sort of perpendicular to that direction. So if you're trying to move, say, from the origin and go directly up, say, in this direction here, you're going to run into these lines which are basically blocking the flow. But if you go at a 45-degree angle, you can see that that's the angle where the flow sort of matches the direction that you're trying to head. And so that's where the flows are going to go. So you can imagine a sketch of this would be something that goes out here, and you can see the flow field starts to bend around, comes through here, goes out the other side, bends around, comes back again. And it does the same thing in the negative direction, right? So you get a solution or a sketch of a solution that looks something like this. Okay, so that's just basically something you can work out by just trying to follow the flow fields and go in the direction that they're telling you that the solution has to bend in. Okay, now the differential equation can be solved by finding solutions to the integral equation below. So basically they've separated the governing equation that was on that first slide, and it separates, and so all the y dependence goes to the left hand side, all the x dependence is written on the right hand side, and now we can integrate these to come up with a solution. And we want to find the equation of the solution of the curve that passes through the origin 0, 0. Okay, so the first thing to do is we'll just write this integral out again, but we'll expand the parentheses here. So we get 2y cubed minus y dy is equal to the integral of x cubed minus x dx. Okay, so now we're integrating. If we integrate 2 times x cubed, we're going to get divide by 4, so we're going to get a half y to the 4 minus a half y squared, and that's going to be equal to a quarter x to the 4 minus a half x squared. And we have to add a constant because we've integrated here. Okay, and now to solve for this value of this constant, we can substitute in the point that we have. So at x equals 0, y equals 0, and so substituting that in, we're going to get a half 0 to the 4 minus a half 0 squared is equal to a quarter 0 to the 4 minus a half 0 squared plus c. And long story short is that c goes to 0 because everything else there is 0 anyway. So you get c equals 0. And so if c equals 0, that means our solution is going to just be those first two terms. Okay, so let me just go to the second page here. And we'll just write, so a half y to the 4 minus a half y squared has to equal a quarter x to the 4 minus a half x squared. Now we can simplify a little bit by multiplying by 2 both sides, and we get y to the 4 minus y squared is equal to a half x to the 4 minus x squared. And if we want to, we can collect some terms together. So we take a y squared out as a common factor, and we can take an x squared out as a common factor. And that's basically as much as we can do in terms of coming up with the way to write the solution. There's nothing you can really do to write y as a function of x or x as a function of y in a way that captures the entire solution. But this relationship here gives you that full figure 8 curve that we plotted on the previous part of this question. Okay, so that was what was required for question 8, and so we'll finish the video here. If you've liked this video and you want to have a look at the other videos, don't forget to subscribe. If you like this video in general, click the like button. Let me know that you enjoyed it. If you have any questions or comments about the video, then you can leave a comment below. All right, and so until next time, that's it. Thanks very much.